Let's take a look at this example. We have limit of the fraction again. We're supposed to look at the denominator. Replace x by 0. You will have sine 3 times 0 gives me 0. We said we do not want to have any zeros in the denominator. So because I have sines in my problem, I'm going to use this formula one more time. But before I'm going to use that formula, I'm going to organize my expression a little bit. I have limit x approaching 0, and I have sine 4x. I'm going to write over 4x. Why? Because I'm trying to apply this rule, sine x over x. And I'm going to have sine 4x over 4x. Now, but you have to keep in mind that this expression, which I'm going to write right now, has to be equivalent to the top one. I have sine 4x over 4x. In order to get just sine 4x, I have to multiply my new expression by 4x. Because 4x and 4x will cancel out, and I'm going to end up with sine 4x. So I'm finished with the numerator. The denominator has sine 3x. Because I have 3x in the denominator, I mean sine 3x in the denominator, I'm supposed to have also 3x in the numerator, because I want to make sure I have 3x and 3x. But in original expression, we didn't have 3x in the numerator. That's why I'm going to multiply this fraction by 1 over 3x, because 3x and 3x will cancel out. Now, let's organize this a little bit, and I'm going to have limit x is approaching 0, and I have sine 4x over 4x, and now I'm going to multiply these two fractions, numerator by numerator, denominator by denominator. I'm going to have 4x over 3x, where x and x will cancel out, times, now I want to get this form when the sine is going to be in the numerator and 3x is going to be in the denominator. That's why I'm going to just simply apply the property of exponents, and I'm going to write sine 3x over 3x to power negative 1. So let's take a look what we are going to have. Now we have limit of the products. We can rewrite this as the product of the limits, and simply write limit x is approaching to 0 of sine 4x over 4x times limit x is approaching 0 of 4 over 3 times limit with x approaching to 0 of sine 3x over 3x to negative 1. I'm going to do everything step by step in order to make you see everything what's going on. According to this formula, sine 4x over 4x with x approaching to 0 is equal 1. Limit of 4 over 3, limit of constant is equal constant. Now, limit of sine 3x over 3x to the exponent negative 1 with x approaching to 0, you can rewrite as limit x approaching to 0 of sine 3x over 3x to power negative 1. This is the way how you can rewrite this expression. 1 times 4/3 is equal 4/3 times limit with x approaching 0 of sine 3x over 3x according to this formula is equal 1. So if 1 to power negative 1, this is equal 4 over 3 times 1 is equal 4 over 3. And this is the solution to my problem. Let's take a look at this example. We have limit with x approaching to 0, tangent x over x. Again, we're supposed to look at the denominator. If you are going to replace this x by 0, we are going to have 0 in the denominator. We said we do not want to have zeros in the denominator. So what we're supposed to do with this example, we are going to rearrange this a little bit. Simply write limit with x approaching to 0 and simply write tangent x times 1 over x. Because this is nothing else, just tangent x over 1 times 1 over x. Tangent times 1 gives me tangent x, and I have 1 times x gives me x. Also, you're supposed to keep in mind that, copy down limit with x approaching to 0, tangent x is equal sine x over cosine x. Of course, times 1 over x. Next, what I'm supposed to do, I'm going to change the position of cosine of x and x. Why? Because I want to get this form. I want to get 1. So I have limit x is approaching 0, and I have sine of x over x times 1 over cosine of x. Now we have the limit of the product. We can convert limit of the product to the product of the limits, and we are going to have limit x approaching to 0 sine x over x times limit x is approaching 0 1 over cosine of x. So limit with x approaching to 0 sine x over x is equal 1 according to this rule. That's why I'm going to write this is 1 times 1 over cosine of 0. Cosine of 0 is equal 1. That's why I'm going to write this as 1 times 1 is equal 1. 1 is the solution to my problem.